we're going to write the equilibrium constant for the dissociation of a weak acid, a Ka value. And we're going to do it for chlorous acid. So chlorous acid, unlike HClO3 and HClO4, is a weak acid. We can write either a Bronsted-Lowry equation or an Arrhenius equation. It doesn't matter, and I'll do both just to show you that the Ka will come out the same either way. So if we start with the Arrhenius definition, HClO2 aqueous in equilibrium with hydrogen ion and ClO2 minus aqueous chlorous ion. If I write the equilibrium constant, like all equilibrium constants, I put products on top. So the concentration of the first ion raised to the power of its coefficient, which is 1, and I don't need to write it, multiplied by the concentration of ClO2, negative, and divided by the reactant concentration of HClO2 aqueous. From the left side, the unionized form. If I write the Bronsted-Lowry equation, the only difference is I write HClO2. I show a reaction with water in equilibrium with hydronium ion and chlorous ion. Now when I write the Ka expression, I have the concentration of H3O plus times the concentration of ClO2 minus and divided by the concentration of reactants, HClO2 aqueous. And because water is a pure liquid, it doesn't get included in the equilibrium constant expression. So I see that the only difference between the two Ka expressions is under Bronsted-Lowry theory, I'm identifying the proton as a hydronium ion, and under the Arrhenius theory, I identify the proton as a hydrogen ion, and the two are mathematically equivalent. If we look up the value for Ka for chlorous acid, we find that its actual Ka value is 1.1 times 10 to the negative 2. The relative size of the Ka value indicates the strength of your weak acid. The larger this number is, the stronger the weak acid is. Now, we know that weak acids, by definition, they ionize less than 100%. These numbers are always small numbers with negative exponents. And just remember that the larger the negative exponent, the smaller the number is becoming. So the larger the number, the stronger your weak acid will be, and the smaller the number, the weaker the weak acid will be.